Hello and welcome back to Verbose Mode by TaxCare, coming to you live from Spring IO 2025. My next guest is my longtime friend Oleg Šelajev. Welcome.
Thank you. Hello.
Oleg, great to have you here. And you are a developer advocate at Docker.
Yes.
Which is obviously absolutely enormously important company for every developer out there. There is no way to kind of overstate how important containers and Docker are for each and every one of us. And it looks like the importance of Docker, which was always there for development and deployment and distribution of stuff, is still there when we are talking about AI as well. And the most fascinating thing for us here is the ability to run local models in the same way that we run containers.
Yep. Right.
So, let me take Estonian. Right. Okay, talk.
Hi. My name is Oleg. Nice to be here. Thank you for bringing me here. Yes. So Docker has recently invested quite a bit of effort into various AI initiatives, and we released a few things, and they are very, very interesting. So probably the more important one is for specifically developers is the Docker Model Runner, which is the technology to run LLMs right in your Docker desktop. With the GPU acceleration and sort of bring the LLM experience into the ecosystem of application development.
How does it work? What does the UX look like? What do you do?
Right. So the same way we run software before with containers and run them in the Docker desktop as the runtime for that, now you have the extended vocabulary of Docker technologies. And we can pull, run, and execute and serve LLMs within Docker Desktop. So Docker Hub becomes a distribution center for AI models. We are storing them as OCI artifacts for some performance optimization, so it's a very interesting topic in itself. But in a nutshell, your Docker Desktop as a client can get the LLM model weights and then execute them within the runtime in Docker Desktop. So that means that you can take your application that requires some access to LLM API. We offer the OpenAI compatible API interface. So your normal workloads that expect an OpenAI API would work with local models via Model Runner. And then you just get the URL, you configure your tools to use that one, and the model runs in Docker Desktop, runs with your GPU. And it's currently available for Mac OS, for Apple Silicon laptops.
Which is the majority of what developers actually use.
Yes, so if you are a developer with Mac OS computer, then probably you are on Apple Silicon, so that gets you covered. And also it's available for Windows with NVIDIA GPU cards. And we're working really hard to bring that to the Docker CE experience, so you can also run that on Linux, which means that you can build it, use it as a building block for your AI-infused applications and run with the setup locally, but also extend it to your CI environments where, for example, you can run your application tests for apps that are using some AI components for whatever functionality you need.
Brilliant. I actually tried it. So one of the talks that I do with Victor Gamov, my colleague and friend, is the comparison between Spring AI and Lantern4j.
Right.
And one of the exercises that we do in both frameworks to showcase how it is done is running local model. And by far the easiest way to run a local model on your Mac is just pull a model into your Docker and then run it using Docker Desktop.
Exactly. You are already using Docker primitives, the containers for running your other dependencies, your databases and stuff. So this just brings the LLM into this
first-class citizen.
First-class citizen. It doesn't run in a container, because on a Mac OS it wants to have the GPU acceleration and that the engine, which is Llama CPP currently, runs as a native host process within Docker Desktop. But it is available both to your host machine and both within the Docker VM.
Yep.
So your containers can talk to it, your host process, your application can talk to it, and like it looks and feels like a proper first-class citizen in Docker ecosystem.
Excellent. What are the customizations that I can do? Can I adjust weights or do anything else?
Right, so currently we're in the early stages, and you can package your models and put them on Docker Hub. This functionality is available. I don't think a lot of companies are still yet doing that. Um, Luckily, this is just the OCI artifact format, so your internal artifact container registries that support OCI artifacts would work the same way, so you don't have to actually publish it publicly on Docker Hub. So if you have a model, and if you can create the gguf file for the model with weights, you can convert that and put it and make it available for your consumption within Docker Desktop.
It's
I
brilliant.
think there is some limitations to the architectures that we're currently supporting. I think mostly this is the Llama model architectures, and we are not yet multi-modal, but for text-based API, this is brilliant. And
Everything that works on Llama will work.
Yes, and it's just like, this is a new project, right? Like we released the first versions back in April, so months ago, literally, and we're gonna get up to speed and support other use cases as well. Probably maybe other runtimes, other engines, not just Llama CPP. It's currently, the architecture is fairly active. There could be more of those multi-models. We're gonna bring it to Linux, so you can use it as the sort of the open source thing, and we want it to become the foundational building primitive for building applications that use AI.
Exciting, exciting. One more question, I think, the relationship between what you want to build in Docker Hub to what already exists as go-to marketplace for models, which is Hugging Face.
Yeah.
What is done there to make it easier to publish at one place and get it to another, to publish both places in the same time?
Right, so Hugging Face is currently the go-to distribution center for, well, machine learning models, and in particular LLMs as well. And it's probably going to stay the same way. They are operating mostly on the Git repository as the format for how they store models. What we have in the packaging mechanism is the sort of the integration with Hugging Face, so you can pull the model from the Hugging Face, transform maybe the safe tensors into the gguf format. You will need some compute power and some hardware, some disk space to actually do the computations and produce the final model files, and then you can publish this to Hub.
So this is pretty seamless. I can take any model once is the type is supported on Docker Hub, and then reformat it and then upload it to either Docker Hub or private registry.
Yes, and then you can consume them from your Docker desktop. And there is a number of advantages to using like OCI artifacts for this, because this is the known format. Companies and enterprises already know how to deal with Docker container registries. They already have the security practices in place for accessing containers. They have the firewall rules to access their container registry from their production environments if they need to pull the Docker images from there. So it's much easier to rely on the existing technology for distribution, and you also, like, OCI artifacts share the same benefits as normal Docker images, which is they're immutable, they have the hashtag, hash code, like they're hashed, right? So there's the layers, all the good stuff is there.
Fingerprinting.
Yes, so, and it might be much more convenient for existing enterprises to rely on the existing technology and distribution paths rather than add a new piece like Hugging Face. Even though I think for the foreseeable future, Hugging Face will probably stay the go-to place for the machine learning and AI community to publish their state-of-the-art models for consumption via some Python scripts and from the libraries.
And also I can think about companies maybe like JFrog, which have support both for proxying Hugging Faces and obviously the private registry implementation in Artifactory to maybe even just move the model from one type of repository to another and doing this conversion on the fly, which obviously will be very useful when Hugging Face is more like a place for data engineers and AI professionals, while the Docker registry is a place for
Yes.
developers and ops. So
Yes.
it kind of makes sense to make
can,
this bridge.
You can think of Hugging Face probably in terms of application development, like vocabulary. It's very similar to GitHub.
Yeah.
It has the sources. You can take them, you can build them. It stores the files there as well. You can put your binary files into your GitHub repository as well.
No, but you really shouldn't.
You have the versioning there. You have the you have also you can build some security measures around that and protocols. But there is a place for the proper artifact repository for distribution.
Always, for sure. Oh, and the UI, right? That's now in beta, but you can already see what models you have by using Docker Desktop, run them directly from there.
Yes.
This is also very nice.
So user experience is there very seamless, and we try to make it similar to containers. You have the new command for the Docker command line called model, so you can do Docker model pull to pull a particular model. You give it a name. You can do Docker model list to see which models are there. You can remove them. The models are also shown in the Docker Desktop UI. You can do Docker model run to get the chat interface right in your command line if you want to do a quick test whether it works. And you also can just you send OpenAI requests to the backend URL, and we have the scheduler that will make the model that you are requesting be scheduled to execute. So you can have multiple models, and you just send requests and say, I would like a Gemma to answer this, or I would like a Quen model to answer this, or
and you do it through the API inside Docker to Docker Desktop. Docker Desktop becomes kind of a single point of contact for any model that you have within.
Yes, you also can do that through the Linux VM for the containers, and then if you want to access the models from the containers, you use the special URL model runner Docker internal at the port 80, and then internally it goes through the VM, but then it gets routed to the appropriate model. That gets loaded, the model responds, the response is sent back to your application. So like it goes seamlessly through one application that is running both your containers and now can serve models.
The Docker server.
Yes.
Yeah. Okay. Now I do have a question. If you don't need to run each and every model separately in order for it to be able to respond, but the Docker server is kind of your single point of entry to all of them, are they all running all the time?
No, there's a scheduler that currently is fairly naive, but we are unloading the models after a certain time of inactivity. And your normal, sort of application development process would be probably say you have a Spring AI-based application, and you configure your backend to be an OpenAI compatible backend in the Docker model runner. You say that you're going to use the model, say Gemma. This is your application properties files configuration, and you're going to use it for a while, right? Maybe you're going to use an embedding model as well for your RAG applications or something. And then when the requests come into those, the model stays loaded in memory. But if you suddenly switch and start requesting, say, from the command line to run a different model, Docker model runner will seamlessly schedule the unloading of some models and loading of other models into your hardware based on how much resources you have
exactly. That was my question. How they
currently the scheduler is fairly naive there, but it's going to get better as well with time.
Excellent. Love it. Okay, folks, you learned a lot.
Yeah.
And you really should give it a try.
Shall we talk about MCP?
Sure. We always need to talk about MCP.
Yes. My favorite. Right. So MCP, Model Context Protocol, which is the thing that took the world by storm, right? Everyone is doing MCPs, and everyone is
for good and for bad, right? There are issues with MCPs.
There are issues with MCPs, but what it is, right? It is the protocol that allows your host applications to talk to language models and give them the wire the available functionality that is written in software to be available to be called by your AI model.
So basically stuff like if you have a piece of software that does, looks for flight tickets, you can expose a protocol that will let AI know that they can call this service with certain types of questions and get back some kind of result that they can present.
So in general, if you take a step back, this is about tool calling that models can do, right? When you build your application and a component there is an AI, which is sort of the non-deterministic black box, you would like it to do certain things for you, mostly creative things, mostly working with like maybe text data, but some things that require precision, that require reliability, you would
require an API basically.
Yeah, you would rather do that in software, especially if you know how to do that in software. For example, if you need to implement mathematical operations, probably it's better to do it in software than ask ChatGPT to add numbers. If you want your application to send like requests to the bank to wire data to a certain account, you might actually have the checksum algorithm implemented in software rather than
for sure you want it.
rather than making your AI kind of look at it and say like, yeah, that credit card looks normal.
This is actually pretty cool because it gives you the benefits of both worlds, right?
Yes.
You can do deterministic algorithmic stuff, and
Exactly.
you can call to it from a prompt interface.
Yes. So how you do that, you say, this is my application, this is the functionality I implemented, and LLM, this is the thing that you can call. And then when the LLM will want to call the tool for you, it will send you a message and say, like, please call the tool X on my behalf. You will run that functionality and then will give you a response back to the LLM. And you can do that with the functionality that you wrote yourself in the code of your, say, host Spring AI application. And our MCP sort of externalizes that tool calling capabilities in what you can think of as libraries for AI, which is the standalone package things, which we call MCP servers, and they embed functionality for what an LLM can do with them, and give the API to the host application to say like, oh, look, I can check your credit card numbers for you, reliably, deterministically written in software.
And they are not really servers. It can be something that is run locally. You don't need any infrastructure for that. In the end of the day, the tools can both run those servers and call those servers, and eventually they just will execute a piece of code for you.
Yes. So this is how you give access to a piece of code to be executed on behalf of an LLM, which is great because you can build agentic systems where AI is actually can do something for you and not just hallucinate things.
Oh yeah, right? That would be useful.
And now this is great because you can package those things and you need to run them. So what Docker has, we worked on the thing called MCP Toolkit, which is the sort of, you can think of it as a gateway that sits in your Docker desktop. You need to run those MCP servers, which are the programs, and sometimes they're written in Node.js, and sometimes they're written in Python, and sometimes you can write them in Java, or it could be something else, or it could be a collection of little scripts that they need to run to actually implement the functionality, and they need to be run somewhere, maybe on your machine, right? So a natural way to run software on your machine is with containers. It gives you the standard interface. It makes all the software be container shaped, which is great, because we know how to work with that. It gives you a certain level of isolation and security. So your MCP server cannot like do random things on your machine. It gives you also isolation from other MCP servers. So if I want to run, say, the credit card validation service as an MCP, and I want to run by mistake, of course, the credit card thief service, they would be isolated. And if I send information to the validation service, it will not necessarily be also available to other MCP servers, which can be malicious, right? So Docker Desktop has this MCP toolkit, which is the gateway, and you can literally go, we have a catalog of supported MCP servers that you can click in Docker Desktop and select the tiles, which functionality you want. And then you configure Docker Desktop as the only MCP server
in your AI tools.
In your AI tools, right?
And it will know all the functions available from all the
selected
servers.
tools.
Amazing.
And when the request will come to the Docker Desktop MCP toolkit server to say call a particular functionality from that particular MCP actual like implemented MCP server, Docker Desktop will run that in the container, pass the request in, execute whatever code is needed there, and then give the response back.
I love it. I love it because, frankly, I tried to run some MCP server that was written in Python, and it was one huge dependency hell for me that
Yeah.
I eventually had to write flags, run it with flags like stuff like break system libraries.
Yeah,
It's a
exactly.
real flag,
Exactly. A
and
lot-
this is what it took to make it
Yes.
run, and it was absolute pain.
And currently, or at least in the last few months, MCPs were very bleeding edge. So nobody was. We were closing eyes on the actual
Yeah,
quirks of the
absolutely.
user experience of
Yes,
there.
definitely.
But a lot of that
definitely.
was like, oh, go to this GitHub repository, copy the npx script that
Exactly.
will actually go to the same GitHub repository, take the latest commit from that,
Yep.
and then execute that, the random code from whoever committed it there
It's so,
on
so
your
it
machine,
was so bad.
and then you give it like access to your like AI data. So this is like it's not ideal, right?
It's
so,
a Wild West.
So the Docker MCP toolkit tries to get some organization to that, tries to give you some more security guarantees and a better way to execute MCP servers on your machine locally.
I love it. How do I take my MCP or maybe MCP that I found that I want to use and make it available inside Docker desktop?
Right. So, that's a good question. I'm a little bit hazy on the details because there is a very much, it's even newer project than the Docker model runner, but essentially there is a catalog of the servers that is available, and I think currently the best way, if you are a vendor and you are building MCP servers for your, for example, backend API systems, and would like to be a part of the MCP toolkit catalog, please talk to us.
Mm-hmm.
If you just want to do that for yourself locally for experimentation,
Yeah.
I think currently the user experience is a little bit convoluted, and you need to add like certain. It's convoluted.
Okay,
Like
well,
it's not yet there, but it will become much easier to add your tools, to create your own catalogs, to have sort of the tool belts of tools that you can plug into particular agents.
Exactly.
Right? So you can be like, oh, today I'm a marketing person and my Claude desktop works with a set
1, 2,
of
3, 4, 5.
marketing
Exactly.
tools.
Yep.
Right? And then today I'm writing code, so my cursor works with my
Exactly.
other set of tools.
Yep.
But it's wonderful, right? One
It
of the
is.
first
It
MCP
is.
servers that I wrote
Yep.
was the Docker container where I would map my project files that would be able to run my tests there.
Exactly.
So when my development environment would randomly change code on me,
Yep.
it can call it tool and actually run the tests.
And the tests are immutable and separated, so
Yes.
the monkey
Yes.
that
But
changes the code
yes.
won't be able to
Exactly.
screw the tests.
And
Exactly.
they also run in the safety of the container, so I can do multiple times of the same thing. I can run tests in parallel if I want. So that was a very cool experiment. So I think it's a very exciting initiative. I think MCP is a very interesting, also quite hyped thing currently. But I'm very excited that Docker is a part of this movement forward and that we can offer some tools to make it a little bit better.
Absolutely. Exciting. You know what? I have an idea for an awesome MCP server right now, which is related to the talk I gave this morning about intent integrity chain. There, I needed two things from not like that are won't be done by LLM.
Yeah.
The first is generating the tests that cannot be touched by LLM, and the second is protecting the tests. And I think what you told me now about containers actually bring them together. I can generate the tests, put them in the container by not using LLM, and then exposing those tests as a MCP server.
Yeah.
How cool is that?
That's amazing. And in the interim, you might not need to use the Docker MCP toolkit because you are building this MCP server yourself.
Yep.
So you can just have a Docker container that has an MCP server in there.
Yep.
And exposing some commands. You can write it in Java. You can
Yep.
write it using Spring framework, Spring Boot application to be the MCP server.
Yep.
And it's just a few lines of code, and it all comes the full loop. We are back in the world where AI is not eating the developers.
Yep.
There will always be software developers. We'll just do things a little bit differently.
And more interesting. And with that, great news for developers. We are not being obsolete. We are stepping up another level of abstraction and dealing with even more exciting things. Oleg, thank you very much. It was a pleasure. And you stay tuned for more episodes of the Verbose Mode by TaxCare here at Spring IO 2025.